All right, mathletes, here we go. 5.2, the unit circle. This is the first day. We'll start talking about it. This is going to be a cornerstone for the next couple of weeks. So next couple of days with unit circle, if you're not getting it, you need to be coming in, getting help. Talk to me at office hours because we got to get this stuff. We can't start running here before we start crawling here with the unit circle. Okay, so some important things with the unit circle that we're going to have to remember is that we're going to have to remember some things from geometry class. So we're going to be dealing with lots of right triangles. So remember our trig functions. It's important that we always were able to identify our right angles and our theta, the angle in question. And from there, we should be able to define our adjacent sides, which I'll abbreviate with A, or ADJ, and our opposites, OPP. Okay, and then our hypotenuse is always opposite our right angle. So regardless of how we get this triangle given to us, we really need to be able to do it in any orientation of a triangle. So if it's turned around like this, we should be able, if our theta is here, identify our right angle, that this side here is going to be opposite, this is adjacent, and that this would be my hypotenuse. So remember, sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite over adjacent. Those are going to be really crucial to understand those as we move forward. So we got to remember these trig ratios here for sine, cosine, and tangent. I like using the acronym Sohcahtoa to help remember that. What's going to be new here in college trig is we're going to talk about the reciprocals of these, or the inverses of these sine, cosine, and tangent. So the inverse tangents are called cosecant, secant, and cotangent. Cosecant is the reciprocal of sine, so it's 1 over sine. Cosecant is the reciprocal of cosine, so it's 1 over cosine. And cotangent, you guessed it, is 1 over tangent. So if we already know what our sine, cosine, and tangents are, cosecant, secant, and cotangent just are the reciprocal. So because sine was originally opposite over hypotenuse, well, cosecant is hypotenuse over opposite, as is secant, the inverse of cosine, is going to be hypotenuse over adjacent, the reciprocal, and then also reciprocate our tangent. So cotangent is equal to tangent. Well, tangent was opposite over adjacent, so it's adjacent over opposite. I think cotangent and tangent, those are pretty easy to remember. How I always kind of remember the inverse reciprocal functions is a C goes to an S, and the S goes to a C. So when you reciprocate it, the first letters change. All right, now that we've talked about cosine, sine, and tangent, and our reciprocals, cosecant, secant, and cotangent, we can start talking about our unit circle. So the unit circle is a convention to help us solve trig problems and interrelate all 6 trig ratios. So with the unit circle, it's called a unit circle because the radius is equal to 1. So no matter where we draw, all radiuses are congruent. So if I draw a radius here, I know that this radius is 1. That radius will have some x component here. I draw a right triangle down from this. My right angle will always be there. I will always have my theta drawn at the vertex and down to my x-axis. Never draw your theta to the y-axis. It is always, remember, your initial side is always your x-axis, so never make the mistake of drawing your theta to your y-axis. Okay, as we did on the first day, our initial side is always our x-axis. So we have our component x there being on that side of the triangle, and then we'll have our component y being there. So the reason we like the unit circle is because our hypotenuse is always 1. So notice when we start looking at these trig functions, if I look at the opposite of my theta over my hypotenuse, I get y over 1, which is just y. So our sign is our y coordinate for any point on our unit circle. So our y coordinate, we can see, will always relate to sine. Okay. Notice our cosine. Our cosine is adjacent over hypotenuse. Well, adjacent is going to be x. Hypotenuse is 1, convenient, eh? And it's equal to x. So I can see my cosine is always going to be my x coordinate. So I got my cosine sine is my x and y. Notice my tangent. So my tangent is opposite over adjacent, y over x. Well, what is y equal to? Well, y is the same thing as sine. And what is x? Well, that's cosine. So this will be more important as we start looking at our trig identities, that the tangent can also be written as a sine over cosine, but it's important to note here. So it's our y over our x. So because we know that the cosecant, secant, and cotangent are reciprocals, I don't necessarily remember hypotenuse over opposite. What I remember is take my sine and flip it. Well, my sine is y. The reciprocal of y and y flipped is 1 over y. The reciprocal of x is 1 over x. And the reciprocal of y over x is, you guessed it, x over y. So you just got to flip those for your reciprocal functions. So that's the basis there of the unit circle, where once we have certain pieces of this, we can conclude the rest of our trig ratios, and that's really the benefit of using this unit circle. Also, while we're on this slide, I want to make note here. Sometimes students have a hard time remembering which one's which for your x and y coordinates. Well, I think the easiest way I remember is in the alphabet, x comes before y, and also in the alphabet, c comes before s. So it's always cosine sine x, y when you're trying to remember that on your unit circle. All right, let's go ahead and look at an example here. So let t be a real number. Let p equal a point on the unit circle. Well, if it's on the unit circle, I know my radius is 1. So what I want to do is I want to find what the sine of t, cosine of t, and all those 6 trig functions are. Well, first thing I'm always going to emphasize is draw a picture. Draw a picture, draw a picture, draw a picture. So if I draw my Cartesian plane here, I know that I go over -1/2. So -1/2 somewhere here. And I go up. So my y is positive. It's going to be over here. I'm talking about this with this here being my t. So my y-axis is square root of 3 over 2. Well, you know what? How do I know that's on the unit circle? So let's verify. If it's on the unit circle, it means it's a radius of 1. There's my right angle. So to verify that it's a radius of 1, I'm going to apply the Pythagorean Theorem. Square root of 3 over 2 squared plus -1 over 2 squared. Well, that's equal to 3 over 4 plus 1 over 4, which is equal to 4 over 4. That's equal to 1. And the square root of 1 is 1, so then I know that my radius here is 1, and hence on the unit circle. Okay, so if I want to go ahead and now apply that and find the cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t, apply what we've learned. Okay, well, because it's on the unit circle, I know that this x and y coordinate corresponds to cosine and sine. So sine of t is equal to square root of 3 over 2. Cosine of t is equal to negative 1 over 2. Tangent of t is equal to, well, I know that tangent is opposite, square root of 3 over 2 over adjacent, negative 1 over 2. Fraction over fraction, not in college trig. We got to simplify this. So to understand to simplify this, this is an elementary operation. I'm going to show you this once. So when I do this, remember that dividing a fraction is the same thing as multiplying by the reciprocal. So, or you might remember it from grade school as copy dot flip. So copy, change it to multiplication, reciprocate, and this is equal to negative square root of 3 over 1. Okay, so now that I have my original 3 trig functions, I can reciprocate those and get my reciprocal functions. So sine of t, reciprocal, s goes to c, so it's cosecant of t is equal to 2 over the square root of 3. All right, can't leave things irrational in the decimal or in the denominator, so we got to rationalize it. So multiply both sides by the square root of 3, or both numerator and denominator. We get 2 square root of 3 over 3. Cosine, flip the c, that goes to s, so that's secant of t is equal to 2 over 1 negative. Rationalize, simplify it to negative 2. Easy enough. Tangent of t. So tangent of t, so reciprocal is cotangent of t. That is equal to the reciprocal of this, so I get 1 over the square root of 3. So negative, and then this reciprocal is going to be, well, it's already reciprocated, but I got to rationalize the denominator. Bust through a square root of 3 on top and bottom, and I get negative square root of 3 over 3. And there you have it. I have all 6 trig answers there for you. All right, this is the last problem that we have this evening. So we're going to find the exact values of each of the 6 trig functions on an angle theta if 4, negative 3 is a point on the terminal side. So this is very different than the last problem that said the point was on the unit circle. This says the point is on the terminal side, meaning our radius is not necessarily 1, and therefore our cosine and sine are just not necessarily, we cannot say the cosine of theta is not equal to 4. We can't say that. Well, we can say that, but we can't say that it's equal to 4. Just like we got to say that the sine of theta is not negative 3. Okay, so we got to kind of deal with that here. So let's go ahead and walk through this and find our 6 trig functions. So first thing I'm going to do is plot, draw a triangle. Always draw a picture. So 4 over 4 down negative 3, I'm going to be somewhere over here. Draw my triangle. Okay, I can draw my theta here to my x-axis, and then I'm going to know that my x parameter is 4, my y is down negative 3. Okay, well, this is a nice Pythagorean triple. You can go ahead and do the math, but you can see that a 4, 3 triangle, I know my hypotenuse must be 5. Hence, we're 5 radius away from our origin. We want to relate things back to the unit circle. That is just a radius of 1. Okay, so we can still use this triangle to help us out. We have all 3 sides, which is really useful now. So I can just, again, use my geometry from before and use Sohcahtoa. So we'll start with sine. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. Tangent of theta, opposite over adjacent. Okay, and it works out really well that we can just find our reciprocals by just flipping them. And it's nice because we have all integer values here, so we don't have to worry about rationalizing. So sine of theta is cosecant of theta, s to c, so we get negative 5/3. Cosine goes to secant of theta, which is equal to 5/4. And tangent of theta goes to cotangent of theta, which is equal to negative 4/3. So there you have it, the 6 trig functions. One thing I want you to kind of notice here is that with our sine and cosine, okay, notice our denominator, 5 and 5. If we just took our triangle over here and divided by 5, okay, that it makes that, there we have a scaled down version that has the same proportions as our larger triangle there. That concludes our lesson today. I'll see you tomorrow.